Are we close to a genome sequencing inflection point? And if so, what's driving it?
So actually, I think we're actually past the inflection point. So basically, towards the end of 2007 and into 2008, the cost of sequencing genomes per megabase dropped from, essentially a few $1,000s to $5. And this drop in cost, has continued, and we're now reaching a point where it will be more cost-effective to just sequence someone's entire genome for clinical diagnostic purposes than it is to use what is the current standard for clinical diagnostics. And so this is really, a big change, and it's coming rapidly.
So I imagine with that change that we're going to see a considerable amount of additional data coming in.
Yeah,
correct?
Yeah.
So what role do you see data scientists and developers playing with that data?
Right. So there's a huge amount of data, first of all. I was just having a conversation with someone at lunch about that, and this is the number one problem. So I think, as far as data scientists go, there's a lot of analysis that needs to be done. Mm-hmm. People who have experience, with things like social networking and sentiment analysis and things like that. Context is very important for this data. So the raw data comes out, but then you have to put it into context with the patient, their background, their history, context of the literature. What are the new scientific findings that are coming out that might be relevant in this particular case? You need to bring all that data together so that someone in a diagnostics lab can make a decision based on what they're seeing. And so I think data scientists in particular sort of have experience doing some of those kinds of tasks. Software developers, there needs to be interfaces built, storage systems built, databases built, web applications to support all this functionality, applications that run on the electronic health record. So it's really, in my opinion, it's really an exciting time because all the things that people already are kind of doing in other areas, they can bring their skills to bear on this problem, and it has obvious benefit for society too.
What are the big issues that genome sequencing is facing? Is it primarily the data issue, or are there other big things that are out there?
So there's a couple things. One, and software, I don't know how much software can do about this, there's a cultural challenge, and that is that medicine has not previously had to deal with a test like this. There is no other test that you can take once and has context the rest of your life. Mm. And so physicians in particular are uncomfortable with this. Most physicians don't have training in genetics. And so, if they do, it was long ago and they don't really remember. Sure. And so this is a very difficult, transition for medicine. But on the software side, yeah, definitely data. Data being the big challenge, just how to store it. I mean, in many cases, it's cheaper to just keep a sample of DNA in a -80 freezer than it is to store it on, spinning rust in a data center. I mean, it's just there's not really, right, an option there. So, but also analysis. I mean, understanding the context, understanding what the results mean. We've never done this before as a human race. I mean, this is the first time through, and we don't know what the context is for a lot of these results, and so bringing disparate pieces of information together so that it makes sense is really, I think, the big challenge.
And I don't want to overstate it, but what you're talking about there sounds like one of the fundamental things that's going to drive the next 25, 50, 75 years.
Yeah, it's a fundamental change in medicine. And it's going to be a major factor. I mean, and I think it's something that sort of snuck up on people. Mm-hmm. So the cost started dropping very rapidly, but it doesn't make headlines on a day-to-day basis, so you don't hear about it. Mm-hmm. But it's coming, and it is going to have a profound impact, and there's huge ethical implications for all of this as well. So that's a major part of our research. As well as what do you do? I mean, how do you handle this? I mean, you're giving people sometimes very sensitive information. Mm-hmm. You're telling them things that they might not otherwise know and might not want to know. And how do we deal with that? And what support systems are in place?
My goodness. So, last question for you, and switching gears a little mm-hmm. bit on this. You work as a lead application scientist at Children's Hospital in Philadelphia. I was wondering if you could kind of walk me through your day-to-day. That's an interesting position.
Yeah, it's a pretty cool job. So really what I do is, I lead teams of software developers and scientists to develop applications to support the research mission as well as things that have an impact in the clinic. And so we're very interested in things that cross the research clinical sort of divide, if you will. And so, on a day-to-day basis, we're having software development meetings, we're whiteboarding things, and we're meeting with clinicians. We're meeting with clinician researchers who have just come from seeing patients, and they come to a meeting with us to look at the latest user interface and talk about ways things need to be represented and what kinds of questions they want to ask. And really our whole group in the Center for Biomedical Informatics is centered around that. We work very closely with researchers, and we bring software technology to bear on research problems that have a very, very clear clinical focus. So it's exciting. We get to sort of sit at the cutting edge of biomedical research and information technology and computer science all at the same time. So we're right at that intersection. So no 2 days are the same.
Right. Well, thanks so much for being with us. Appreciate you taking the time.
Thanks.